30 years ago, people talk about climate change, and it was just a word to us, climate change. Today we're seeing so much difference on the land, the water, it's just the weather, and even the animals. They act differently every year. They're mixed up with timing, weather. They're all confused, but they know just as good as us. It's changing.
This project, looking at the impacts of landscape change on the streams and rivers of the Peel Plateau, was started a few years back in response to observations of large-scale landscape change by local land users as well as land use inspectors. And we were able to put together a team of multidisciplinary scientists as well as land users to work together to try to understand what some of these changes are and how they might be impacting the rivers and streams of this area. And as it turns out, this landscape, the Peel Plateau, is probably one of the most dramatically changing landscapes in Canada, if not in North America. It's underlain by ice-rich permafrost. There's a lot of relief and a lot of fast-flowing streams. The melting of the ground ice is causing huge landscape disturbances. As our research is showing, these are having profound impacts on the small streams, but also on larger streams and even the Peel River. Stephen Tedlici is a land user, a harvester based out of Fort McPherson. He spends a lot of time in the land. He knows the landscape very well. He's always talking about his observations when we're out in the field. I think he's been able to really provide a lot of insight into some of the projects that we're doing, partly because he's seen so much of the landscape, and he also very often refers to things that he's heard from the elders about the way that the land has changed and where certain species are found or certain environmental phenomena exist. He just has a tremendous ability to be able to sort of connect and put together the information that he has that's developed from a traditional knowledge perspective and link it with the scientific observations that we're making. Stephanie Delaney is a master's student at Carleton University, and Stephanie is a studying to be a paleolimnologist. What Stephanie's trying to answer using lake sediments is whether or not the changes that we're seeing today in the last 20, 30 years in the Peel Plateau, are they unique in any way, or has this type of thing always been happening on the landscape? And the ability to look at lake sediments allows you to actually go much further back in time and look at how the environment has changed over time. So in lakes, sediments are deposited over time. These are sediments that might come in from the landscape, from rivers that feed into lakes. And there's a large set of lakes just to the north of Fort McPherson called the Husky Lakes, which are an abandoned channel of the Peel River. And there are many streams that flow into that lake. Some are impacted by very, very large thaw slumps, and others that are not. And these slumps are putting significant amounts of sediment into Husky Lake. So those sediments go into the water column and then eventually settle out in the lake bottom. So Stephanie has obtained cores that go down to 6 meters. And we did this in the wintertime through collaborating with another researcher, Scott Lamoureux, from Queen's University. And we had Clifford Vanelsi out, and we obtained these cores. And then Stephanie will look at the accumulation of sediment in the lake bottom and look at the rates of sediment accumulation, the nature of sediment accumulation, and also potentially some of the changes in the biological system that have occurred over the history of the lake. And as the sediments accumulate, organisms that live in the lake, particularly single-celled plankton and smaller organisms like that, when they die, their skeletons, many of them are made out of calcium, and the skeletons will settle to the bottom of the lake and accumulate. And by looking at the type of organisms that are in the water column, that can give us an indication of what the environment was like at that time. So by looking at those changes over time as the sediments in the lake accumulate, we can learn a lot about how the environment has changed.
I work in the same area as Steve Raquel, who monitors permafrost and studies thaw slumps. Ours is a different focus on vegetation, but in the same area, and still part of the same story of environmental change, affected by the same disturbances and increasing temperatures. My supervisor is Trevor Lance from the University of Victoria, and he's worked in the Peel Plateau monitoring vegetation for several years and has a history of collaboration with the Northwest Territories Cumulative Impact Monitoring Program and with people from Fort McPherson.
My name is Trevor Lance. I'm a professor here at the University of Victoria in the School of Environmental Studies. And my students and I here focus on trying to understand landscape change in the Western Arctic. And we do that by, I guess, using a number of different approaches and tools. The first of which, and one of the things that gets us out into the field a lot in the summertime and a little bit in the wintertime, is our field investigations, so where we actually go out and measure soils and vegetation and all those kinds of things fairly intensively at locations across the Western Arctic. We also do a lot of work with satellite images and historical air photos, which allows us to kind of scale up the work that we do in the field to a bigger, larger area of the landscape. And so we work with historical air photos that go back in some cases to the 30s and on up to satellite images that were taken just this past summer. And then the third approach that we have used for about the past 7 or 8 years or so is working with knowledgeable landholders in and around the communities that we work in. So we've been really fortunate to be able to work with land users and hunters and trappers that are actively on the land, spending a lot of time on the land, and we're able to learn a lot about what's happening out there from those knowledgeable folks.
The objective of the photo monitoring project is to create a comprehensive record of environmental change in this area. There have been big changes in plants. People are noticing a lot more shrubs growing in areas that used to be open and growing really tall where they used to be short. That can make traveling more difficult because they have to clear the shrubs where they've grown into people's trails. People have been noticing differences in the animals that are around here and in their behaviors. People are seeing new types of birds that never used to be in this area, or different insects that they've never seen before.
Even animals are confused now with weather because of the climate change. At one time we used to know when the animals are going to migrate. Now they're mating early. That just takes it away from the trapping.
The cumulative impacts of all these changes to the environment need to be understood, and the Dempster Highway is one that hasn't been researched and is one of the pieces of the puzzle that we need to understand the cumulative impacts in the area.
This is a slump, a small ground ice slump. It would have formed, it started to retreat up the slope to the edge of the Dempster, and you can see the Dempster Highway is now starting to subside. So in order to mitigate, the Department of Transport has put gravel and tried to infill the slump with some, I guess, moderate success at this point. Another thing that you can see here is that even the gravel they're putting into the slump is creeping down slope there. The gravel you can see has been already pushed down into the base of the valley, and this has all happened really in the last year. You can see the original materials that went into the valley are located here, and that's pushed the creek over to the other side of the valley and caused the water to start eroding the opposite slope, which has created another slump, which you can see right against the valley side over here. So in the Peel Plateau and in sediments that are pushed up against the Richardson Mountains and the Mackenzie Mountains, there's huge volumes of ground ice that have been preserved since the last glaciation. And some of this ice is comprised of buried glacier ice. Some of it also consists of ice that formed as permafrost degraded into these sediments. And the ice, which you can see by the folded layers in the exposure behind me, is almost pure. If you took a chunk of that sediment and thawed it, about 90% of it would be water and about 10% of it would be sediment. So if this type of sediment is exposed to thawing, the consequences are pretty significant because the ground will subside proportional to the amount of ice that's in the sediment. So in terms of understanding where this ice is, how broadly it is distributed, is really a key to understanding the landscape sensitivity to climate change and terrain disturbance.
In the summer, we during this time of the year, we end up going out on the land to berry pick and fish for the winter. And people that when they go out today, they always say it's so much changes. The reason we know the land so well is because we've been here for thousands of years. Our ancestors, and they pass it on to us, and that's our livelihood. That's how we live.